Welcome to What If. Today's topic, Earth's hidden alchemy. What if we could soon power our world from what is beneath our feet?
Okay, so have you ever stopped to think about what's right under our feet? I mean, not just like dirt and rocks, but like way down there,
Deeper than the subway.
way deeper. Imagine tapping into the earth itself, almost like it's a giant battery or a wellspring of resources we never even knew existed.
Well, I've been looking at some materials that touch on exactly that. Underground hydrogen and ammonia production, using what's already down there.
So we're not digging stuff up, we're actually creating stuff down there.
Right. It's like using the Earth's own internal pressure, heat, even specific types of rocks, things like basalt and talc, to basically cook up hydrogen and ammonia on demand.
Now, this is perfect for our listeners, always eager to learn about big ideas quickly. Today's deep dive is all about getting into the nitty-gritty, the truly unusual possibilities that this kind of tech could unlock. We're talking about those aha moments, and we're lucky enough to have some great sources to draw from today.
Absolutely. Plus, it's not just theoretical anymore. You've got companies like Addis Energy already making moves in this space, actually putting these ideas into practice. Is becoming real.
So our mission today is to explore the most intriguing, even speculative sides of underground hydrogen and ammonia, the stuff that makes you go, hold on, could that actually work? But before we get too far ahead of ourselves, let's lay some groundwork. We're talking about hydrogen and ammonia. These aren't exactly household names for most folks.
True, but they're vital. Just look at the numbers. Global demand for hydrogen is already enormous, something like 97 million tons. That's everything from refining metals to making fertilizer, even powering rockets.
And don't forget, hydrogen is a big part of the clean energy future we hear so much about, right? Fuel cells, storing energy from renewables.
Exactly. The U.S. National Clean Hydrogen Strategy, which we see mentioned in these materials, really highlights its potential there.
Okay, so hydrogen, big deal. But what about ammonia? I know it's in fertilizer, but is that it?
Fertilizer is huge, almost 180 million tons globally. Think about how vital that is to feeding the planet. But ammonia is versatile. We're talking refrigerants, water purification, even some types of plastics.
Wow, so both of these chemicals, already essential, could be produced in a whole new way. So now let's get to the good stuff, the speculative, the mind-blowing potential of it all.
Right. Let's say this takes off. Underground production becomes the norm. Economically, things could get very interesting.
Like how so?
Well, you mentioned localized energy production earlier. What if this leads to these self-sufficient energy islands, communities, or even whole regions that don't rely on the traditional energy grid at all? They've got their own resources right there under their feet.
Energy islands. I like that. And then what happens to economics on those islands? Do they change?
They could, right. Imagine instead of relying on global oil prices or whatever, they trade based on how much hydrogen or ammonia they're producing locally, almost like a regional energy credit system.
That's pretty wild. And what about on a global scale? Like, think geopolitics. Could this shift things?
Oh, absolutely. Imagine nations with the perfect geology for this. Think huge basalt deposits, the ideal conditions for underground production. Suddenly, they're the new power players, not because of oil, but because of what's under their land.
Right, like a whole new era of geopolitics where it's not about controlling oil fields, but about georesources, as we might call them. Could we see like a geocurrency backed by how much hydrogen or ammonia a country can produce underground?
It sounds like science fiction, but is it really that far-fetched? This kind of production could be incredibly stable and reliable.
So energy islands, geocurrency, what else could be turned upside down?
Well, agriculture could undergo a radical transformation. What if we're producing so much cheap ammonia locally, right in urban centers, that vertical farms become the norm? Suddenly, vast fields of traditional crops might not make economic sense.
It's like flipping the whole system on its head. And all that land that was used for farming, what happens to it?
Who knows? Maybe we see a resurgence of wilderness, huge rewilding projects. Maybe those spaces are used in entirely new ways we haven't even thought of yet.
Okay, so we've got these massive economic and agricultural shifts. What about the everyday person? How would this impact daily life?
Well, our materials mention cleaner air, more resilient communities. But imagine this. What if this tech really empowers a move towards off-grid living? We're talking about subterranean homesteading, where people, or Maybe small communities tap into their local underground resources for everything. Energy, fertilizer. They're completely self-sufficient.
Whoa, that's a pretty radical shift in lifestyle. Imagine no more utility bills, no more reliance on big agricultural corporations. It's almost a return to a more, I don't know, self-reliant way of life.
Right. And speaking of self-reliance, think about this. What if this readily available underground hydrogen leads to super efficient, tiny fuel cells? We're talking about powering your phone, your laptop for years, maybe even decades on a single charge.
No more charging your phone every night. That would change everything.
Right. It would totally disrupt our relationship with energy consumption. We'd have to rethink how we design and build our devices.
It's almost like a whole new era of technology, all powered by what's beneath our feet. And think about what this abundant ammonia could do for food. If we can produce it locally, right in cities, we could see a huge boom in urban gardening, community farms, rooftop gardens.
Yeah, hyper-local food systems. Imagine knowing exactly where your food comes from, even growing it yourself,
Yeah.
right in the heart of the city. It's a total shift from the industrial agriculture model we have now.
And imagine the impact on remote communities, places that are usually at the end of long, fragile supply chains. Could they become self-sufficient, even hubs of innovation, using this tech to become energy and food independent?
It's a pretty empowering idea, especially for communities that have historically been marginalized or underserved. But now let's turn to some of the bigger questions. The ethical stuff.
Yeah, because with every new tech, there are always those what-ifs.
Absolutely. I mean, on the surface, our materials talk about environmental damage, who owns these resources, but I think it goes deeper than that. If we can alter the subsurface environment to produce these chemicals, what are our obligations to the planet itself? These geological processes, they've been happening for millennia. Could we be messing with something we don't fully understand?
It's a huge question, right? I mean, we often think about protecting the environment above ground, but what about the environment below? Do we have a responsibility to those ecosystems too?
And let's say these resources are deemed part of a global commons. How do you ethically manage access and distribution, especially if some regions have way more of these resources than others? It could create a whole new type of global inequality.
It's like we've always thought about resources in terms of what's on the surface, but this opens up a whole new dimension of resource control and all the ethical dilemmas that come with it. And what about the potential for, I don't know, let's call it geo-trespassing?
Geo-trespass?
Yeah, like what if a country has the tech to access resources that are technically under another country's territory, even if they're drilling from within their own borders? What are the rules there?
Whoa, that's a geopolitical minefield. And that raises another issue. What happens if we reach a point of near limitless resources, as some of the more speculative scenarios suggest? Is that actually a good thing?
Right. I mean, it sounds utopian, but could it devalue human ingenuity, our drive to be resourceful and solve problems? Could it lead to crazy levels of consumption and waste, even if the production itself is sustainable?
These are profound ethical and philosophical questions that we need to grapple with now, before this tech really takes off. We need to be prepared for those potential consequences.
Okay, so we've talked about the economic upheaval, the social changes, the ethical dilemmas. What about the environment? I know cleaner air is mentioned, but what about the less obvious impacts?
Well, our materials mention the risk of leaks, but let's think bigger. What if this underground production could be used for geoengineering? Not just capturing carbon, but influencing geothermal activity, even local weather patterns.
That's getting into some serious, I don't know, almost godlike powers, right? Tinkering with the Earth's systems on a fundamental level. And what about the things we don't know about?
Exactly. We're still learning about the Earth's interior. What if we accidentally release some unknown gas or trigger some unforeseen geological process? The consequences could be unpredictable.
And let's not forget about the life that exists down there, those subterranean ecosystems, the microbes and all that. We're just starting to understand that world. Large-scale extraction could have a huge impact on these organisms.
Right. It's a whole hidden biosphere that we need to consider. We can't just assume it won't be affected. And all of this, of course, ties back to geopolitics. Our materials suggest a shift away from the traditional energy superpowers. But could it be even more radical than that?
Like what? What are you thinking?
Well, imagine new international alliances forming, not based on ideology or geography, but solely on access to these geo-resources. Countries with an abundance of basalt suddenly becoming best friends, even if they were rivals before.
It's like the map of global power gets completely redrawn, not by wars or treaties, but by geology. Fascinating. And what if those alliances give rise to something totally new, like subterranean intelligence?
Subterranean intelligence.
Yeah, like nations investing in crazy tech to map and monitor, maybe even control these resources globally. It becomes this whole new realm of espionage and strategic competition.
Wow. So we're not just talking about energy independence, we're talking about a potential geo-arms race of sorts.
Right. It's wild to think about. Okay, so we've covered economics, geopolitics, the environment. What about how all of this could affect our cultures, how we view the world and ourselves?
Our materials mention increased environmental awareness, a sense of local ownership. But I think it could go much deeper than that. Could we see the rise of new Earth-centric philosophies or even religions that see the planet as a living provider? Maybe rituals or traditions that connect to these geological cycles.
Right. It's like we become more in tune with the planet, not just in a scientific way, but in a spiritual or cultural way. And how would this impact our sense of time? Imagine we're interacting with processes that happen over millions of years.
It could really give us a new perspective, right? A deeper sense of connection to the planet's history and its future.
And what about art? Could we see new art forms inspired by this connection to the Earth's interior? Like geo-art, created by manipulating geological formations, or music composed from the sounds of the Earth itself?
It's fascinating to imagine how this could inspire creativity and push the boundaries of art.
But on the flip side, what if all this abundance makes us lazy? Like if we have unlimited energy and resources right there, do we lose our drive to be innovative, to conserve, to be resourceful?
That's a really interesting point. It's like the paradox of plenty, right?
Yeah.
Could too much abundance make us vulnerable in ways we don't anticipate?
Exactly. Okay, so we've covered a lot of ground here, from the practical to the philosophical. But now, as requested, let's really push the boundaries. Let's talk about the truly outlandish possibilities, the what-ifs that might be closer to science fiction than science fact.
Okay, I'm game. Let's go full-on speculative here.
All right, so your materials mention underground refueling stations on other planets.
Right. Imagine we land on Mars, and instead of lugging fuel all the way from Earth, we tap into the subsurface water ice and use local production to make hydrogen fuel.
It's like turning those planets into pit stops for space exploration. And what about the idea of seeding lifeless planets with catalysts to kickstart terraforming from within? Imagine injecting these catalysts into the subsurface of a barren world and watching it transform over time.
It's like playing planetary architect, using these tiny catalysts to unlock a whole cascade of changes that could eventually lead to a habitable planet.
Mind-blowing stuff. Okay, now let's talk about something closer to home but equally wild. Your materials mention self-sufficient subterranean cities powered by bioluminescence fueled by underground hydrogen. Can you paint us a picture of what that would look like?
Imagine descending deep underground into a vast cavern. The air is clean and fresh, and a soft, ethereal glow illuminates the space. This is a city powered by living organisms, their bioluminescence fueled by the constant, reliable supply of hydrogen from the Earth itself. Closed-loop ecosystems recycle everything, creating a truly sustainable and self-contained world.
It's almost like a return to the womb, right? Safe, protected, completely independent from the harshness of the surface world. And what about us humans? Could we adapt to utilize these resources directly?
That's where things get really interesting. We're talking about biological integration, maybe through engineered symbiosis. Imagine future humans with gut bacteria that can break down hydrogen for energy, or crops with roots that tap directly into underground ammonia veins, like a natural fertilizer fee.
Wow. So we're not just using the Earth's resources, we're becoming part of the Earth's systems in a whole new way. That's a pretty profound thought.
It raises all sorts of questions about what it means to be human and our relationship with the planet. And let's push this even further. Imagine harnessing these underground reactions for large-scale climate control. We're talking about sequestering carbon, neutralizing greenhouse gases, even something like geothermal acupuncture to subtly influence the Earth's internal heat balance.
It's like we're becoming planetary doctors, right? Diagnosing and treating the Earth's ailments from the inside out. And if we can achieve all this, create this post-scarcity world fueled by Earth's abundance, what does it mean for humanity?
That's the biggest question of all, right?
Yeah.
What happens to our values, our goals, our purpose when basic needs are met? Do we turn our attention to exploration, to creativity, to spiritual pursuits? Can we finally achieve a global unity, realizing that we're all interconnected, not just to each other, but to the planet itself?
It's a truly transformative vision of the future. And like your first source asks, these are provocative questions for future exploration. Questions about our relationship with nature, the potential for greater equality or even new forms of imbalance, and the immense ethical responsibility that comes with wielding this kind of power. It's all pretty mind-blowing.
It really highlights how interconnected everything is, and how even seemingly technical innovations like this can ripple out to affect every aspect of our lives.
Absolutely. Now, just to bring it back down to earth a bit, your materials mention a few pathways to global adoption, some practical steps.
Right. We're talking about ongoing research to refine these technologies, pilot projects to see how they work in real-world settings, developing the infrastructure to support this new kind of resource extraction and distribution, and most importantly, international cooperation. This can't be a solo effort.
No, this is something that needs global collaboration and shared knowledge, and I think that's a great note to end on. We've covered a lot today, from the nitty-gritty science to the truly mind-bending possibilities and everything in between.
It's amazing how this one idea, underground hydrogen and ammonia production, has opened up such a vast and diverse landscape of potential futures.
Consider this. If we can truly learn to tap into the Earth's inner potential in a sustainable and ethical way, are we on the verge of not just a technological revolution, but a fundamental shift in how we understand our planet and our place within its vast and interconnected systems? What other hidden potentials might be waiting to be discovered right beneath our feet?
Our podcast AI Voices are courtesy of Notebook LM and 11 Labs, the humans and AIs of the AI Plus Roundtable. Thank you for joining us on this journey into uncharted territories.
Visit us on Substack at airoad.substack.com for free access to our other expeditions into the unknown. We thank our producers, the humans at Innovation Toronto and ChatGPT, Claude, Cohere, Copilot, DeepSeek, 11 Labs, Gemini, Grok, Llama, Mistral, Notebook LM, and Perplexity for co-creating the research used to create this podcast. We look forward to welcoming you on board for our next explorations into uncharted territories.